As mentioned, my name is Darrell Covell. I'm the Strategic Technology Advisor for Axellio Incorporated. And while Axellio's headquarters is in Colorado Springs, Colorado, I and a few others are around the DC Beltway area. I'm actually just a few miles west of the Columbia, Maryland area. I mentioned such in event once the pandemic is under control, I and my team are happy to meet for whiteboard sessions with regards to certain features of our product that fit and or can be configured, tailored. As we all know, one size doesn't always fit all of our customers' applications. My point is that we are a very agile and flexible company. In short, my background is 30 years starting companies dealing in radar, sonar, acoustic problems. That always required my need to have the highest compute and storage platforms that were available at such time. I later got involved almost 20 years ago in packet capture, PCAP, DPI, DPM, and doing some very unique things with packets and supporting DoD USG entities. Thus, again, my desire to always find the most high-end compute processing and storage platforms that currently exist in the market. This desire and need is what drove and excited me to join the Axellio team. We greatly appreciate you all affording your time today and with the webinar. With me on the session is Mark Zeller. Mark is the Chief Revenue Officer for Axellio, who has been with the company for about 6 years, who will be speaking soon. I also want to quickly insert that we do have additional members that are not on this call that bring certain skill sets in cybersecurity, threat hunting, digital forensics, and incident response. If we can go to the agenda slide. Okay, we're going to be talking about the company overview, next generation compute, network packet capture. What is not mentioned on here is our product, and hopefully we can get to it, that drastically reduces the size into a portable, rugged implementation of our compute platform. We will be very mindful of the clock so as we have sufficient time to close with any Q&A that you may have. You can go to the corporate overview. Perfect. As I mentioned, Axellio is located in a rich high-tech area of Colorado Springs, Colorado. A brief snapshot history, 1997. Pioneered storage solutions with 25 years creating 100+ patents from a very specialized group within Seagate. 2018, Axellio. Axellio spun out from XIO to commercialize solutions addressing the needs for data centers and computing on the edge. That brought Axellio FabricXpress, which is a very innovative hyper-converged infrastructure solution, as well as Axellio PacketXpress, from the NIC edge for high-speed packet capture to high-speed processing of such and the analysis of. Listed below is just a subset of customers. This list will be growing in the very near term as Axellio is having tremendous success and growth, and we would be happy to share as well as share reference customers' point of contacts if that helps at your request. We can discuss during this presentation certain problems that we've helped these firms, entities solve in more detail to the degree that is proper. Next slide, please. I won't spend too much time on this. Axellio, IT insight and performance, high-speed analytics for IT operations with investment protection, industry, defense and intelligence, commercial enterprise, IT ops, network security and application operations, network, data center, core, network edge. Next slide, please. Addressing the pressing issues of today. As we all know, the ever rapid growth explosion in the amount of data, a problem everyone is dealing with. More data for more and more sources at higher speeds both will continue to grow. The growing risk in cybersecurity, in volume, severity, and complexity to deal with, and the scarcity of appropriate resources. The significant growth in not just the amount of data that is transported across the network, which is reflected by the number of high-speed links that are deployed throughout the network, it's also the growing risk in volume of security attacks in your environment overall. This is made even worse with the lack of skilled resources to deal with the onslaught of information. It really drives computing power even further out to the edge. Because of that growing volume, you need to have more of that processing at the edge of the network. In other words, the tactical edge or front end line of defense. And lastly, the typical problem, as there is a continued reduction in acquisition and operation costs, which really limits the number of solutions you can deploy in order to resolve those issues in dealing with the growth of the data volume and security while being cost sensitive. So in essence, in short, we have to do all of this by doing more with less dollars. At this point in time, I'd like to introduce Mark Zeller and turn it over to him. Mark?
Thank you, Darrell. Really appreciate that. Good morning, everyone, or afternoon if you're on the East Coast. During this section, I will be discussing the technical basis for Axellio's packet capture system and how we achieve 100 gigabytes of aggregate packet capture while simultaneously distributing those packets to security sensors, network monitoring sensors, and application performance monitoring sensors. This is a view of our Axellio architecture. In order to actually provide the capabilities to deliver these high speeds, we actually develop very high performance hardware using COTS technology as much as possible, but to actually provide the highest level of performance, we developed the centerpiece of this technology called Xpress Fabric. So our technology is based on standard off-the-shelf processors from Intel, storage. That storage is NVMe protocol storage or all-flash drives that also utilize a dual-ported technology versus most traditional servers using a single-ported. The network cards, in this particular solution, most of what we're going to talk about today is network capture, network packet capture. We partner with nopatech to provide those 100 gig capture cards as well. So again, the centerpiece is this technology called Xpress Fabric, which then allows for a lot of the features you're going to see here. So Axellio, as Darrell talked about, was in the storage business for quite a long time. We were working on our 4th generation storage array in a skunkworks project we entered into with Intel in order to prove out the NVMe protocol. This was back in 2015, 2016. And we actually ended up developing a device that was pretty powerful. The question that Intel asked us and what we had to answer ourselves is, now that NVMe drives are available, which actually connect directly into a PCIe fabric versus SAS and SATA drives, which actually have to connect into a card that then connects into the PCIe fabric. The question was, how do we get the most out of them? It was a new protocol based on SSD versus SAS and SATA are actually based on old, what some people refer to as spinning rust technology, the mechanical disk drives that most of us are used to. The protocol itself, NVMe versus SAS, which is faster than SATA, provides a 6 times performance increase over SAS drives by themselves. So how do you get the most out of that? And the answer turned out to be Xpress Fabric, which utilizes the PCIe version 3 lanes, which within the Intel processors to connect to as many dual-ported NVMe drives as possible, while ensuring the bandwidth will be optimized based on the I/O capabilities of the drives. And I'll have some slides later that will explain that statement further. Xpress Fabric was created through the implementation of a highly switched PCIe fabric analogous to a storage SAN on the chassis itself. So if you're familiar with SAN technology, it's a fan-out, highly complex networking solution to actually ensure that all of your data gets to your processors as fast as possible, reliable as possible, and with very few bottlenecks. Our initial design, which we called at the time the FX1000, actually provided 120 gigabit bytes, that's big bytes of throughput within the system. Since then, with a combination of design and Cascade-like processors, we have driven the total chassis throughput to up to 240 gigabytes per second, which is pretty phenomenal. If you think about the fact that most traditional servers are probably around 12, and most of the commodity ones are between 3 and 5. So that's a pretty significant improvement. In addition to our newest iteration of the product, which we call the 2000, allows for a very flexible lane assignment based on the mission. So we can add accelerators like GPUs, FPGAs, et cetera, along with 48 NVMe drives and a 3U chassis. From a processing perspective, we're using dual socket servers in a chassis utilizing Intel Xeon processors, as I mentioned. Each chassis actually has 2 of those dual socket servers. We utilize 40 lanes per server for a grand total of 160 lanes that provide this unique amount of bandwidth. And I'm spending time on this just to give you a perspective, because if you have big data problems, you need a lot of bandwidth to ingest, process, and distribute that data. So moving on, our current capacity right now using 16 terabyte NVMe drives is 725 terabytes, again in a 3U form factor. In Q4, we'll be introducing 32 terabyte drives, which will actually double that to 1.5 petabytes. So pretty significant density within that platform. Finally, our packet capture solution, we partner with nopatech to provide the 100 gig lossless packet capture. They also provide burst rates up to 200 gigabits per second, and we'll talk a little bit more about that. I have a detailed slide on that later. In addition to the nopatech cards, we though also support any standard networking option from Mellanox, Axellio, Intel, as well as specialized connectivity for such applications as L-band satellite type data that we can collect. So that is a basic overview of what we provide, and kind of the centerpiece is this fabric, this Xpress fabric that is technology that, as far as we know, nobody else can deliver. So this is basically a summary of that slide. So again, we've provided a very dense, very fast, flexible architecture to meet many missions and use cases. We call this solution, and we'll discuss it a little bit later on, PacketXpress, not to be confused with Xpress Fabric, which is the underlying technology for our server technology that we currently have. So what I'm going to do is kind of give you a quick view of the COTS technology that we're currently implementing. So all of our solutions are utilizing Intel Xeon scalable Generation 2 chips. Anywhere from a platinum processor down to a bronze processor, depending on your speed. We can actually also use different processors on each server within the farm, as they all actually support the 48 lanes that the scalable family provides. The other thing that we utilize, and again, I've kind of mentioned this, but we utilize the NVMe drives for this. And the reason we do that is 2 reasons. A, the protocol, which I've already mentioned, is 6 times faster. But the other factor is these directly connect into the PCIe bus. They provide speeds of 2 gigabytes per second versus a typical SATA drive is about 600 megabytes. A very expensive SSD, SAS SSD, is about 1.5 gigabytes. But the difference is this technology here, when you look at the storage controller, you can only connect 16 PCIe lanes to one of the more expensive controllers on the market, which creates a mismatch. That particular control unit actually has the capability to attach 36 SSDs. So that's a aggregate total potential rate of 54 gigabytes versus the capability of 16 gigabytes from the PCIe network. Whereas utilizing NVMe drives allows you to fully capitalize on that, especially when you have a technology like Xpress Fabric. So here's just a quick comparison about traditional server architectures versus our architecture. So typically what you'll get is, a server that might have up to 36. Most of them really can only store about 24, connected to a by 8 or a by 16 PCIe lane to one dedicated server. Again, the important point here is this red arrow about the 54 gigabytes of throughput potential bottleneck down to 16 gigabytes. So when you are doing a packet capture solution or any fast sensor solution that requires no data loss, the capabilities of these internal processors are very important. However, there are traditional servers or servers on the market where you can actually have NVMe drives connected directly to that, but most manufacturers only provide a by 4 to a couple units. There are some out on the market right now that can attach 24 drives, but it's to a single server and a single ported NVMe drive. So in a sense, you're limited to about half of the capability of an NVMe drive, as it's a highly parallel protocol. And that brings us to, when you look at a comparison between the Xpress architecture, you see here Xpress Fabric at the centerpiece here with the 160 lanes that are dynamically configurable. You see, 2 lanes go into each NVMe drive versus 1 lane going to the NVMe drives. In addition, those NVMe drives are connected to multiple servers, and depending on the software you're using, and we'll talk about that in our packet capture software, you need software that will actually allow for the data on those drives to be visible to both servers. Something like Hadoop does that, and other open source solutions, as well as file systems. And finally, before we get off this technology, this is just a quick overview of our partner's nopatech card that we use for our packet capture solution. This is a really amazing piece of technology based on FPGA or field programmable gate array technology. They actually developed the software for this and provide the capability for 100 gig line rate data capture or packet capture, while actually allowing for burst rates up to 200 gigabytes per second because of the large onboard buffer that they have. They also have several functions that you typically would see in a packet broker or a tap aggregator that's a pretty expensive piece of equipment. They actually will do filtering, deduplication, slicing, among other services. And the packets are time-stamped up to or down to a nanosecond timestamp resolution. In addition, they do offer time sync, precision timing capabilities across the environment. So they're a great partner. We're very happy we're working with them. They develop great software, and we've integrated their software into our packet capture solution. So this is a summary of the technology basically in a block diagram. So this picture is actually based on our PacketXpress appliance, but you see that on one server we have a SmartNIC and the 2 Xeon CPUs. On server 2, we actually have what we call a distribution NIC, which is a standard NIC that we use to distribute the data to other sensors. In between there is our Xpress fabric, 160 configurable lanes attached to whatever you want to do it to. On your right here, you see some of the hero numbers and a little bit more of a description of what the product is capable of. Before we move to the packet capture, I just want to give a little bit more. So we discussed PacketXpress, which is the ARX 2000 or 1000, in which you can deploy multiple solutions using open source solutions, or we actually sell HCI solutions from VMware and Microsoft on that platform as well. Then we have PacketXpress, which is our packet capture appliance, in which we've developed specialized software to optimize taking the data off the nopatech card and persisting it to storage, and we'll talk more about those features later. From a hardware perspective, utilizing Xpress Fabric, we have two platforms. I've already talked to you about the ARX platform. We also have a mobile platform that we are in the process of developing with the Air Force as we speak. So on your right, you see a picture of the 3U ARX 2000. We're actively deploying that in a Garrison defensive platform for defensive cyber operations under an OTA contract. Here is a picture of the mobile device, and just to give you a quick perspective on this, this is actually a carry-on, standard carry-on suitcase that you could fit into one of those little things that the airlines ask you to put your suitcase in to see if it's too big. Within that, we can actually, using our Xpress Fabric, integrate 6 server nodes that have the dual socket CPUs on them, or a combination of servers like that, up to 6 GPUs, and we're talking beefy GPUs like a V100, as well as have the capability to have up to 24 or 2.5-inch U.2 NVMe drives for the capability when the 32 terabyte drives come out, 725 terabytes within one of these boxes. Many of you might have attended a trade show where you've seen similar form factors of processors, but those processors or those solutions, carry-on solutions, are typically between 400 and 800 watts of power, which limits the capability to put those enterprise class processors that I showed you earlier, the Xeon Scalables. It limits your capability to put a powerful GPU like a V100 on, which is about 250 watts by itself, and it limits your capability for how much storage you can put on there. So essentially, this is almost a data center in a box that will be ruggedized and capable to run our PacketXpress software, as well as any of the open source ecosystem partners you saw earlier. And actually, you didn't see them earlier. I'm showing them to you right now, but here's just a overview of the partners that we work with in the various areas. So, you know, we mentioned the platform softwares. You've got your Hortonworks, Hadoop type environment, Microsoft HCI, Azure Stack HCI, and VMware vSAN type solutions, as well as Red Hat and other solutions. I've already talked about the hardware partners that we have from a front-end perspective as well as a GPU perspective. And then you see some of our network operations partner as well as our security operations partners. So just a vast array of open source and proprietary software that can be used on our platforms. So at this point, I am going to get into the network packet capture and why it's important and how we actually solve those problems. Okay, so let's start with kind of a problem statement, if you will. So there's 4 areas of business that typically want to look at this network and traffic data. It's typically network operations, security operations, application operations. There is a company called Enterprise Management Associates, which is actually located in Denver, Colorado. Does a study annually. Their 2018 study actually showed the top 4 challenges of getting network fabric visibility. So one of the key ones, or the biggest problem that all respondents talked about, was infrastructure complexity. So networks are actually pretty complex these days from both a physical as well as a virtual perspective. They're not well understood. You know, they grow fast, and it's hard to document and show everything that's possible. So you spend a lot of time and energy even ensuring, you know, what's on your network, if it's protected, and whether you can actually get the network visibility from your monitoring tools. The second factor that is pretty big, and I'm sure we're all aware of, is a lack of personnel skills. And we see that lack of skills in 2 areas. Networking skills have long been a gap in the employment sector. And what we're seeing now, especially in the security area, is a lack of threat hunters, which is why, you know, as Darrell mentioned, we brought on an actual certified threat hunter to actually help us and our customers with our product development. The third piece there, and this is very important, is the scalability of the networks. We all know that, you know, 1 gig networks are probably on the downside. 10 gig is the most prevalent right now. There's some moving to 40 gig, and 100 gigs are a far cry, but starting to become very important. Aggregate traffic, though, is huge, even in these 10 and 40 gig networks. And that's why we developed this capability around generating that 100 gig line speed solution. And then finally, you know, the traffic can overwhelm the visibility fabric. So if you think about, I've got a Zeek instance, for example, or 2 that is right now working well in my environment. As soon as my traffic starts to grow, it starts to burst more, I can start dropping packets. So it's critically important to ensure that that there's a way to better manage how your sensors get the data, which will actually decrease the complexity of doing that. And then again, all of this actually leads to why, in a 2019 study that IBM did, basically said your average time to identify and contain a security breach is about 245 days. So you can see that these problems are huge. If you get a network breach, you know, for some of the folks on this call and our customer and some of our customers, you know, it's a national security issue. For our commercial customers, it's loss of reputation, stock price loss, legal issues, all sorts of bad stuff that you read about in the paper quite actually more frequently than you want to. So here's a quick study, just again to say why network packet capture is so important. This is specific based on a Stamus Network study about the effects of packet loss on an intrusion detection system. But what it identifies is that if you lose 3% of your packets, you will miss 10% of the alerts that you would have gotten in the first place. You take that up to 25% packet loss, and you miss about 50% of your packet traffic. Also, what this same study found is that with a 5.5% packet loss in your capture environment, 50% of the extractions that you request to analyze an alert do not have the data that is important in actually understanding what the threat was, mitigating the threat, and validating your fix. So again, the ability to capture packets reliably is critically important in this type of environment. So how does Axellio solve that problem? We actually do it. PacketXpress is a 3-in-1 solution, right? We actually do the high-speed packet capture recording at 100 gigabits line rate, burst up to 200, as I've said, probably more times than you care to hear, as well as distribute that data. Also, because we can distribute that data, we can distribute multiple copies to multiple tools, multiple streams to a single tool, depending on the size of the actual traffic that you're ingesting. And that actually allows you to extend the useful life of your current monitoring investment and analysis, as well as slow the growth of that, depending on your network growth. And finally, we provide a platform for universal analytics across the board. So again, all of this will give you more network visibility, reduce the amount of time to root cause, and save yourselves quite a bit of money and reputation as far as data breaches. So I'm going to break these down into a little more detail. So Axellio PacketXpress. Currently, we are state-of-the-art solutions that can do or claim to do 100 gigabit per second packet capture are literally a half a rack to a rack full of equipment. They actually don't even use the SSD drives that are SAS and SATA. Most of them actually use that protocol on the spinning rust or mechanical drives of today. So what they can do is they can capture at a certain rate. The majority of them are 10 gig, 25 gig. A really fast one is 40 gig. To get 100 gig, they actually put multiples of those together. Also, to be able to index in these environments, they actually have to index in advance and select those index points. One of our competitors actually, when they turn indexing on, their capture speed goes from, say, 40 gigs down to 30 gigabit per second. So it actually reduces your ability to capture packets by 25%. And when you're not capturing them, you're losing them in these environments. So that balance is critical. And then finally, when you're actually doing an analysis, to be able to extract those is a very low priority. And threat hunters have told me they've waited hours to actually get an extraction from these types of solutions. So what does PacketXpress bring to the table? Well, because we can do 100 gig sustained intake and 100 gig simultaneous write outside the environment, we actually don't have to slow down for indexing or extraction. In fact, we do a 5-tuple indexing, but we actually on the in the solution utilize the Berkeley packet filter to actually allow you to request your packet flows based on any criteria that you would like. So it's really a totally different, very dense, very fast packet recorder. Now let's move to the adaptive traffic distribution, which to me is actually one of the key benefits of this. So what you see here is, in your typical network environment, you don't go at 10 gigs, you don't go at 40 gigs, you don't go at 100 gigs, you go at 1.5 gigs, you go at maybe 20 gigs and maybe 60 gigs. But every once in a while, you spike up and you're going over those rates, right? So the critical impact of that is that your network gets bursty and you lose packets during that period of time. And one of the interesting things about, say, a network intrusion is usually the adversary uses a distraction called the denial of service attack. So they will literally drive up your traffic, burst it so that you're losing the packets, which will again, result in lack of visibility and a more successful intrusion. What we do by capturing all these packets and timestamping them and then being able to distribute them to your sensors is we actually buffer that traffic so that your monitoring tools get every packet that they need to identify an intrusion that you can react to it and take that react to it and mitigate that as quickly as possible. So, and again, the way we can do this is, again, we can duplicate traffic across multiple applications. So we capture once and distribute the same data to multiple. We can actually do this to 16 streams. So it's actually pretty powerful as far as what you can fan out to. We can actually also say, from this IP range, from this VLAN range, send this traffic because, you do have a large network that is getting utilized greatly. So again, this is a critical software function that we provide in order to ensure that that you have full network visibility. And then, finally, the uh-oh. Can you guys see my, sorry about that. We're almost at the end here. So finally, we have the Universal Analytics Platform, which is the capability to actually run some of these sensors like Zeek on the equipment itself and distribute it to your other sensors, whether it be in a private cloud, etc. So it's application agnostic. Currently, we're using KVM. We plan to use containers for this. And, if we need to do a VMware solution, we can do that as well. But our current solution is based on KVM, and anything that runs in a KVM environment can run on this onboard Universal Analytics platform. And then here's just a real world use case of this. This is an example of the GDP version 3 product that we're working on with the Army. We're partnering with a company out of Columbia, Maryland called Ceiling Tech, who has provided us most of our integration and networking skills in order to accomplish this for the Army. Their mission requirements are simple. We need to defend our networks at our bases, both in the continental US and outside the continental US. And we wanted to be able to do this at 100 gigabit per second aggregate rate, store and index that, and then actually integrate that into a private cloud on the environment. So given that, here's how this is implemented as we speak. So we're tapping into the Garrison network. Our preference is to actually use a passive tap. However, in some instances, we are using span ports, R spans, and ER spans, depending on what the network architecture is. We have the capability through the SmartNIC to connect multiple 10 gigs across the networks, as well as multiple 40 gigs, and actually can connect to 200 gigs, but that we're still limited to a line rate of 100 gigs with that burst up to 200. We capture the software, and then the software is distributed. We're distributing to a couple Zeek sensors on the server node itself, what we call the reader node, as well as set up multiple streams to several other sensors in the DCO tool environment on the private cloud. All of the alerts are forwarded from the sensors to a Splunk indexer using the Splunk forwarder technology. Once a soldier sees an alert, our plan in the future is actually to develop something for Splunk base and actually allow you to pivot directly from the Splunk Splunk indexer into our extractor software. However, currently we're running a Python retriever and capability off a Windows environment in the cloud. So again, real world example, being actually run in several bases now, and hopefully by the end of the quarter, tens of bases and more, but a real world example of what we're actually achieving. So again, that's the last slide. It covers our hardware technology, the software that we developed to actually do this Axellio packet capture. And we end on this platform. And at this point, I'd like to thank you and